Question number 3, you can mark this question important. Now, this is a quadrilateral ABCD. Now, mind you, it's not a trapezium, it's just a quadrilateral. So, don't assume that these are parallel lines. So, ABCD is a quadrilateral and AD and BC are the diagonals intersecting at a point O. The question is, prove that the ratio of areas of the triangle ABC and DBC is equal to AO by DO. Okay, we have to prove that ratio of areas of ABC and DBC are AO by DO. Now this will require a construction. The construction is we are drawing these perpendiculars AL and DM perpendicular to the common base BC for the two triangles. Okay, so that's why this is in dotted. Any construction line will be in dotted. Now we know the formula for area of triangle. Area of triangle is half base into height. So area of this triangle ABC will be half BC multiplied by AL. Area of the triangle will be half BC into AL. And area of triangle DBC again will be half base into height. So half BC into DM. So here half BC is getting cancelled because this is a common base for both the triangles. Half is getting cancelled and what are we left with? AL by DM. But we need to prove that ratio of areas of ABC and DBC is equal to AO by DO. So the next step will be to prove that AL by DM is the same as AO by DO, and for that we will be taking the triangle AOL, this triangle here, and triangle DOC and prove them, DOM, and prove them similar. So we are taking AOL, this triangle here, and triangle DOM. Angle 1 and 2 are vertically opposite angles, and by construction angle L and M are 90. So triangle AOL will be similar to triangle DOM by AA. Now once we prove that the triangles are similar, then the sides are in proportion. So we can say that AL by DM is the same as AO by DO. Okay, AL by DM is the same as AO by DO. And we can put this as equation number 2. Now substitute this here. So what will happen? Area of ABC by area of DBC is equal to, instead of AL by DM, we are replacing with AO by DO, and then we get the required result. So hence proved. Moving on to question number 4, we are given two triangles whose areas are equal. Okay, ABC and DEF are two triangles whose areas are equal, and it is also given that the triangles are similar. So we are given that the areas are equal and triangles are similar, and we need to prove that the triangles are congruent. So since the triangles are already given similar, we can apply the theorem ratio of areas of two similar triangles is equal to the ratio of the square of their corresponding sides. So area of ABC by area of DEF will be equal to AB square by DE square, or BC square by EF square, or AC square by DF square, right? And since the areas are equal, when we cancel this, because anything which is equal in numerator and denominator, that will become 1. Okay, 10 upon 10 is 1, 100 upon 100 is 1. So these two are equal given, so we get 1 here. So when we cross multiply each of these terms with 1, what do we get? AB square equal to DE square, BC square equal to EF square, and AC square equal to DF square. We are cross multiplying each of these quantities here with 1. And if the squares are equal, the number itself will be equal. So I am cancelling all the squares. So we get AB equal to DE, BC equal to EF, and AC equal to DF. And therefore, we can say the triangles are congruent by SSS, because all the three corresponding sides of the two triangles are equal.